Traveling at the speed of light, the future of interstellar journeys. How humanity envisions breaking the barriers of light-speed travel and exploring the stars. Traveling at the speed of light has been one of humanity's most captivating dreams. From the imaginative worlds of science fiction to the ambitious visions of physicists and space agencies, the idea of surpassing our cosmic limits sparks awe and curiosity. Yet while the fantasy of cruising between the stars in mere moments is exhilarating, the reality of interstellar travel is bound by the laws of physics, human physiology, and technological innovation. In this article, we will explore what traveling at the speed of light would mean for humanity, the challenges we face in reaching such speeds, and the possibilities of achieving interstellar journeys in the not-so-distant future. The speed of light, a cosmic limit. In physics, the speed of light, approximately 299,792 kilometers per second, is the ultimate speed limit of the universe. According to Einstein's theory of relativity, no object with mass can reach or exceed this velocity. As a spacecraft accelerates closer to the speed of light, it requires exponentially more energy, approaching infinity at light speed. This makes the idea of a spaceship reaching that velocity seem impossible with our current understanding of physics. What happens at light speed? If it were possible to reach light speed, the universe would appear radically different. From the traveler's perspective, distances would contract dramatically due to Lorentz contraction. Stars ahead might blur into streaks of light, while cosmic radiation would intensify dangerously. The journey would feel instantaneous for those aboard, yet decades, centuries, or even millennia could pass on Earth. Relativity and time dilation. Einstein's special relativity tells us that time slows down for objects moving near the speed of light. This means astronauts traveling at such speeds could experience only a few years of aging while centuries unfold back on Earth. The emotional implications of this are profound. Astronauts might return to a planet that has advanced far beyond recognition, where loved ones are long gone, and society has transformed completely. The human experience of light-speed travel beyond the physics, the human experience of such journeys is just as important. Imagine being one of the first explorers leaving Earth behind for an interstellar mission. The courage, isolation, and sense of destiny would be overwhelming. Traveling at or near light speed would not only test technology, but also challenge our psychology, emotions, and ability to cope with the vastness of space. For many, the journey itself would become a defining experience of human resilience and identity. Would we still feel connected to Earth when centuries pass in a heartbeat? Or would we evolve into a new kind of interstellar civilization? Technological barriers to light-speed travel. Currently, the barriers to light-speed travel are immense. Some of the most critical include energy requirements. Accelerating a spacecraft to near-light speeds would require energy comparable to the total output of stars. Radiation hazards. At high speeds, even tiny particles of space dust could hit a spacecraft with the force of nuclear explosions. Human biology. The human body is not built to withstand extreme radiation and long-term exposure to microgravity. Material science. No known materials can endure the stresses of such travel without disintegrating. Alternative paths, near light speed, and warp concepts. Since true light speed travel appears unreachable with current science, researchers explore alternatives. These include near light speed travel, using concepts such as antimatter engines, nuclear pulse propulsion, or light sails powered by lasers. Spacecraft could approach significant fractions of the speed of light. Warp drives, inspired by science fiction, the idea of bending or warping space-time itself could, in theory, allow faster-than-light travel without violating relativity. Though purely theoretical, the Alcubierre drive concept continues to spark debate in scientific communities. Interstellar journeys, the next frontier. Even if we cannot reach the speed of light, humanity's vision of interstellar travel is far from dead. Projects like Breakthrough Starshot aim to send small probes propelled by powerful lasers to nearby stars at up to 20% the speed of light. Such missions could reach Alpha Centauri within a human lifetime. For larger spacecraft carrying people, slower but sustainable methods may be the solution, such as generation ships, where multiple generations live and die aboard the vessel before it reaches its destination. The human spirit of exploration. At its heart, the dream of light-speed travel is about more than science. It's about the human spirit. We are explorers by nature, compelled to reach beyond horizons and imagine new worlds. Interstellar travel represents not only technological ambition, but also a profound expression of hope, that humanity can survive, thrive, and spread its light among the stars. Even if traveling at the speed of light remains out of reach, the journey toward that goal will drive innovation, inspire generations, and redefine our place in the cosmos. Traveling at the speed of light is both a scientific challenge and a philosophical question. While the laws of physics may never allow us to truly achieve it, the pursuit of interstellar journeys will transform how we live, think, and imagine the future. What matters most is not whether we reach the speed of light, but how the quest itself will shape humanity's destiny among the stars.